All right. Good day, everyone. Welcome once again to KodeCamp DevOps Engineering Bootcamp. We spoke about Docker in our previous class, and we are going to look at some practical applications of Docker and containerization today. Um, so welcome back. Um, right now I'm sharing my screen. We're looking at the Hub, the Docker Hub image repository. This is a public repository where we have different Docker images from various people, various organizations. Um, right now, these are the verified Docker official images, as you can see here. That's what I've selected here. So we're looking at the Docker verified images, and we see many tools that are containerized and uploaded here for us to work with. We are going to take our first example, our first test, using the Nginx image. We're going to set up a simple Nginx. We're going to work with that. So this is what we're going to work with. Um, I'm going to share my terminal. So of course, I have my Docker running. So what I'm going to do is, first of all, I'm going to list my images. Okay. So there's no Nginx here. I'm going to now pull an Nginx image into my repository. That's Docker pull Nginx. Now this would automatically pull the latest version of Nginx. But if I want to specify a particular version, I can do that by doing either Nginx and putting the particular tag that I want to specify. But right now, I'm just going to pull my Nginx image directly from Docker Hub. And it's using the tag latest by default. And it's going to basically pull this image for me. And then when I list my images, I'll be able to see it as one of the images that I have here. And so this is working on pulling this now. Okay. So it has completely downloaded that image. And if I list out my images again, and I'll see that I have Nginx right here. Right. If I want to pull a particular version of Nginx, right, I can do that using the tag. Maybe I want to pull version 1.26.1 Alpine, right? Do 1.26.1 dash Alpine for this particular tag here. This one, right? So I'm going to pull that, and let's pull that image. If I list out my images again, I can see that I have the Nginx latest here and the Nginx with the 1.26.1 Alpine, right? Okay, so the next thing we're going to do, we're going to run this Nginx image. Um, we're going to run it as a container on our local machine, right? Okay. So there's nothing running on port 3000 right now. I'm going to run my Nginx image. So to simply run it up, a simple way to quickly run it would be to do docker run, and I can name it, set a name for it. Maybe I want to name it KodeCamp Nginx, right? And set the ports 3000. So this will point the ports on my host machine to a port in the container, right? So my host port, it points out to the container port. So for my host, if I go to the port 8080 on my hosts, that will direct the traffic to port 80 on the container. And I'm going to run the Nginx image. If I want to run it with, I want to run the 1.26 Alpine, I can also specify that. I'm just going to run the first one, which is the latest one, right? Um, so I can run that. I'm not running it in detached mode. So when I run it, it will basically run here on my terminal, and you can see the logs on that. So let me run this. Okay. So this has started the container. I can list my containers here. Okay. So listing out my containers, you can see that this container is running. This Nginx container is running. So I'm going to go to my local host now. And we can see that we have Nginx running on that port 8080 on my local host. So I've used a container and set up a web server running on Docker within my machine right now. So that's the basic demonstration of how Docker works. I can also do this with, say I want to run a database, for instance. Okay. Before that, I will show something else. Let me end this. Okay. So I've exited that process, and that image is down. I can run this in detached mode if I don't want the logs to be coming up right here. So I can just run it in detached mode by putting the option, the flag -d. That's this, or spelling it out. So with detached mode, it runs it in the background instead of having it in the foreground like this. Okay. This container still running. Okay. So I'm going to stop this container. Okay. So I've started this in this container in detached mode, and it just brings out the image ID of the container running, but it doesn't show me the processes running and the logs of it. But if I come and still do the Docker PS, I can still see that the container, if we run the container and come in here again, I can see that the container is back up. Right. So I have Nginx running and I can stop it. Can stop the container by doing the and that has stopped the container. Let's try to run another application, right? This time we are going to try to run a database. Still on our local machine. Um, so I'm opening an app, PG admin, which is for Postgres, right? This will just demonstrate how we can also run a database machine. Let's do that demonstration using Post. Okay. So let's try to pull our Postgres image and try to run that on our server. Basically, looking at the documentation, this shows us how to start a Postgres server. So I'm sure we can even try to start this without explicitly pulling it, because I think that should pull it by itself. And to run it, there are some required environmental variables that we have to pass, such as the secrets that will be used to create the Postgres secrets. And it uses the default Postgres username and admin, especially except to specify that otherwise, and we can access it using any application of our choice. So I'm going to run this now. Right. I'm going to do Docker run. Set the name to, of course, KodeCamp Postgres. Then the environmental variables, you can set environmental variables using -e, and The required one is Postgres password. Of course, in a production or in a real world scenario, you will want to have this secrets stored securely, not just specifying it in your command line like this. But for the case of demonstration, I'm going to have the password here. Right. So I'm going to set that to my password. I'm going to run it in the detached mode and run Postgres. Right. I haven't pulled this yet, but I want to check whether I want to show you whether or not to run without us pulling it into our environment. If we pull that by itself. So I'm going to run this. So it says, first of all, that it's unable to find Postgres latest in our locally in our repository. So it goes ahead and pulls that by itself, right, from Docker Hub. So it's pulling the Postgres image now, and then it will run this database server for us. Okay. So let's see what's. So you see that Postgres is running right here. Right, it's running on port 5432, which is the default port for Postgres. And the name KC Postgres server. This ran with the default username for Postgres here, Postgres, because we did not specify a specific username. If we wanted to do that, we could have done that using the username variable, Postgres user variable. So let's come to our PG admin, which is basically a tool, a software that you can use to access databases, Postgres databases in the UI format. So I'm going to name the database tests KC. Server. This is the server. Connections, I'm going to put the host's name, which is my local host. Five, 4, 3, 2. Main database Postgres username. The password, let me put in the password, which I specified as KC password 1, 2, 3, 4, 5. Let's test the connection. Okay. Server name. Five, 4, 3, 2, of course. Okay, what's the problem here? Someone have a question? Abdul, you have a question? Hello, I see some hands up. You guys, you can't hear me?
Can hear you.
I can hear you. Please go ahead with your question.
supposed to be preset. Thinking.
I can't hear you.
Hello?
What did you say? Okay. So the host name should have it should be the full domain name. Go ahead, Abiri. Hello.
Yeah, good evening, sir.
Evening.
Yeah, so wondering how do we get your PG admin, the interface? Is it
I'm just using that to demonstrate. We can sort that out later. You can just download it on your own, but it's just I'm just trying to demonstrate how it will work. I can also do that in the terminal. If that will be better.
yeah, because I don't have that interface. So but if it's a prerequisite, that means we need to download it.
It's really not. It's not at all.
Okay.
I think if I do this terminal. Next into server. Let's do this again. I'm going to let me see.
Can you hear me now, sir?
Yes, I can hear you.
Yeah, I think the local host address is wrong somehow. You type in 127.0.0.0.0.0.1. Okay,
wow.
yeah.
I don't think that's a problem, but thank you. That was a mistake. Not sure this is a different server. This is a different error now. Okay. Let me see what this is running. Okay. So let me take this down and try to set it up again, right? I'm going to stop this KC. Let's should I take it out? Because it's still be okay. Going to remove it. Okay. Then I'm going to try to run that again, right? And I'm going to specify the ports. do some form of forwarding to my local host. Let me take out the detached mode. So that this can, get traffic from my local, on my host machine and direct it to the ports on that container. Okay. So let's see the error we got. The file belongs to. It's telling me I specified the ports wrongly. So they are valid. That isn't running. So I'll do that one more time. So Postgres is running now. Let me look at the container. Let's have that one. This is simply happening because because of our networking setup, right? This container is running on something called a bridge network, and we need to be able to forward the traffic from coming from on our host to this container, right? If I show you the container right here, if I can just find it. Let me see. I named it KC Postgres, right? Okay. If I inspect it, And I can do that here using what I was using describe for. I can use the command inspect, and it shows me everything about this this container that is running right now. So in the network setting, I can see right here, network setting, right? I can see that it's running on a bridge network in the networks here. So it's running on the bridge network. And that's why in the other one, when we set up the Nginx, we had to do that port mapping where we did something like this, something that looks like this, dash P 8080 to 80, right? So this forwarded traffic, when traffic comes to 8080 on our hosts, it forwards that traffic to port 80 in the container. That's what this did. But we tried to do that when we were starting, and it was telling us that that wouldn't work. So I need to find a way to direct the traffic. Can I do a port forwarding? I don't think that works in Docker. That's more of a that command like this. Let me find out. No, there's no command like that. Let me exec into it. And that will give me execution privileges so that I can execute commands. I'm going to get an interactive terminal. Then I'm going to do KC Postgres, right? And let's see, KC Postgres and okay, I command okay. So I've executed into an interactive terminal on that Postgres machine. That's Postgres container now. Right here, you see this terminal here. I hope you can now see this. It has changed to roots 3 dot. This is the ID of our container. If I come to describe here, the inspect, you can see the ID has this ID name 362FDD. So you can see the roots at 36. So I'm inside the container right now. If I do who am I? Okay, obviously roots. If I do ls, right? So let me do PSQL on that. And that's will error code. Let me come to my beautiful documentation here. So this is here. PSQL dash username. Postgres. Okay, so here you have Postgres. I've logged into Postgres now. So right now, I'm on the Postgres server inside on the Postgres user on that server, and I'll be able to execute Postgres commands here. And I can do create or show databases. Show DBs. Show users. I create table. Wait, let me execute a Postgres command here. Maybe to create okay, well, so inside the container, I'm able to access Postgres. I could try running this on the host network, right? Let me exit out of here, right? And Docker networks. Sorry. Docker network list, right? And I can see the networks here. This host network. If I run the Postgres here, then perhaps I can access it using that local host. So let's try that. I can stop this now, right? And basically stop the Postgres that is running. Stop the Postgres that is running. And Okay. Right, I think, yeah. So let's specify the network to be the host network. Yes, let's run that. Yeah, this is not the value that I'm putting for the network. Okay. Let's go into creating Docker files while we still have time. We can come back to this. But we see that the Postgres container is running. It's just to connect to it using our local host, here from our local host. So that should be part of what we talk about when we speak about networking. right. So moving on to Docker networks, as we came to that. So in our last class, we spoke about how there are various types of network. There's a bridge network, which you can create and have various containers run within your network. It's like a virtual network you can create. And you also have your host network, which is the network of your host, of your computer or server that you're running on. Yeah. These are host network. And our bridge network. You can also create a network of your own. If you want a separate network that you can deploy your containers on. So I have created a network and it has returned the network ID to me. If I do Docker network list again, we now see that I have my KC network here, which has been created. And I can now decide to run I can decide to run my containers using a particular network. So I've created this Nginx image on my KC network. Let me create another. This would be the, let's create the database server again. Perhaps the different name. We're going to do Docker run. Okay, so I'm going to list out my networks now, Docker network. Right, and if I inspect that KC network that I created, I see the subnets that's created. Containers. Is this running? So we've seen how to create a network and how to create a container that will run on a particular network. The next thing and final thing we want to talk about is how to create a Docker file, which will help us to Dockerize an application that we want to work with. So to do this, we would we'll go into our Python for DevOps. Our Python for DevOps folder as we worked in our Python class. And here we can see some of the Python scripts that we worked with here. I'm going to open this in my text editor and see how we can work on that. This code. Okay, so this application, this code that we wrote here was, I think we used this to create okay, so it creates a folder and it creates a particular file within that folder, right? Makes a directory within a folder. All the resources. Create resource. Okay, create resource. Okay, so it creates an Ubuntu image using vagrants within a particular folder. Okay, so we are going to Dockerize this application and run it as a container. We have a few minutes more. So to do that, you can simply create a Docker file. Okay. Okay, So we are going to create a Docker file here. So this Docker file is what we are going to use to Dockerize this application. The first thing to do is to specify your base image. The base image that you want to, because Docker works by layering images on top of each other. So you're going to specify the first base image that you're going to use. So we can do that. Let's look for the best one we can use. We can come into the Docker Explorer, Docker Hub Explorer. I see Python, right? So I can use a Python Alpine. I'm going to use this as my base image, Python 3.12 Alpine. So specify your base image you're going to use from, and you're just going to get the name and the tag, which in my case is Python 3.12 Alpine. So this is my base image. That's the image that it's going to build the rest of my container on top of, right? To create my image. The next thing I could do is to copy the files that I need from my present working directory to the container. But before that, I'm going to specify a working directory. I'm going to specify a directory within the container that all of the processes are going to execute in. So I can do work directory, right? And I'm just going to specify that as app, right? So this is my working directory. When the container is run, it will be executing it will be running the next commands in this directory called /app. I can now I want to copy this particular application. Which one was it? I think, no. Yes, Python automate 2. So I'm going to copy Python automate 2.py. I'm going to copy it from my local into my /app directory. And since it's the working directory, I'll just specify that as here. Another command that you can use in a Docker file is your expose command. Although we might not need to expose this application since it's not exactly a web application, it's just like a simple worker to perform a particular task. But if it was a web application, I need to expose it on a particular port, you can use your expose command for your Docker file and either expose it on port 3000, ports 80, any ports that you need to expose it on. Another important command is your run command. You can use this to run any command within your application, right? I can use this now to run lists, which will list out the different files in this my working directory. You can use this to, depending on the application you're building, you can use it to do your installations. Maybe you have a requirements file, for instance, and you want to to pip install. You can use this, do your pip install, and specify your requirements .txt. You can use this if you're working with a node application. You can use this run command to do your npm build, your npm install, just the commands that you usually run on your command line, and you want Docker to run it within the image. You can use it to do that. So I'm just going to use it to run my list, to list out the different files and folders that are in that directory. After that, I can then create my entry point for my application, which would be Python 3. Python list. So this is just the same as doing Python 3 Python .py. Okay, let me put that .py. Really important. So this command will now execute the application. So this is a simple Docker file, right? Which will so let's see. So we see our Docker file here. We can that's that, and see different steps here. Okay. So these are the various steps that to go through to create this file. And to create the file, we can simply do Docker build. Right now we are in a, remember, print working directory, we are in this Python for DevOps. And in here is where we have the Docker file, right? So that's why we can do something like Docker build and specify that it should build here. It should build here. It should build in this directory that we're presently in by using that dot. So that dot tells us that it should build, within that the present directory, because that's where the Docker file is. So to use that Docker file to build, we can also tag it. We can also create a tag, and we can name it create Ubuntu latest. This will be the tag. We can also put the tag as version 1.0 if we want to. So this command will build this and target thus, and we can now execute that. So it's building right now. It has done the first step, which is to pull that Docker Alpine. So that's what it's doing right now. Okay. Still pulling the image. Okay. So you see that this is step 1 of 4. It's did the from to pull this image. This is step 2, where it sets the working directory. Step 3, where it copies the Python automate into a folder. Then step 4, to run the ls. When we do the when we run that image and to do the execute or the entry point command, so we can come to Docker images to see our images, and we will see create Ubuntu 1.0, right? So we've created this image, and we've basically, what we've done now is to Dockerize this, let's call it an application, this Python application, right? This that Python program application, we just Dockerized it. Yes, so we can now run this. This okay. Okay. This might try to get this image from the Docker Hub. Okay. Let's specify which is supposed to be the okay. So let's look at our Docker file again. Let's try using just Python. Invalid operand. Let's try it on our local machine. Python automates 2.py. That has an error in it. So it seems our application has an error. So it also has an error in the Docker file, obviously. When we create the Docker, when we try to run the Docker image. So let's try to see if we can sort that out here. Moments. Let's we're changing our Docker file to send this one instead, since that one is working well. So we rebuild that as version 2. Images. Okay, so we have 2.0 here. Let's Docker start that. Running that again. Okay. Okay. So we are missing a comma. Let's try building that again. So blue indicates that that's completed that step. We still have some steps here that are yet to complete, so it's still packaging and building the application for us. This is going to take a while. I'm seeing here that it's done 33 MB out of 200. So while that is building, let me show you the last task, the last step, which is to push an image to Docker Hub. Right, I'm logging into Docker now from my command line. There are some, because I've logged in before. If this is your first time, you probably need to go over the process again, but there are some credentials that have been saved to my local machine, which was just used to log into it now. So I've logged into my Docker, which is this Docker hub here, which I should probably log in here, by the way, too. Okay, we are on. Okay, so that's the name. That's the name. So this container ran and exited after 33 seconds. So we're not able to see it up. Let me see the logs on that, if it shows the logs. So it's not staying up running. So what we are going to do in the next class is to build a Flask application, which will just give us a simple API so we can connect to a container that we create. So in this class, we have shown how to run a Docker image from Docker Hub and how to create our own container. I'm not going to go into how to push it for today, but we can do that in the next class because of time. So I'll just take some questions now, based on what we've done already. If there's any aspect you don't understand. Hello? If there are any questions, just put up your hand and I can call you. Hello, Ahmed. You want to go ahead?
Hi, Michael. I didn't raise up my hand for question.
There was an Ahmed had. There was an Ahmed.
Oh, okay. Okay, okay.
All right. So I think we can bring the class to an end here. And in our next class, we're going to create a simple API application where we will work with Flask, and we are going to expose that to our local network and be able to access the container from our local network. And then we will go to container orchestration from there. All right. So thank you so much for joining, and goodbye.